Good morning, my fabulous chemistry students. Lecture number 1, starting redox today. There are only 6 videos in this unit. One will be very long, one will be super short, and nonetheless, let's get through this. Remember, if you complete all of your lectures during spring break, lunch is on me, just so we're all clear on that. Ready? First notes, understand oxidation and reduction is related to loss and gain of electrons. This is a mnemonic we can use. Leo goes grr. I'm also going to give you another mnemonic that I like better personally. So I'll give you both. We also need to be able to identify is an oxidation or a reduction happening. Okay, so those oxidation numbers in the periodic table, those little plus and minuses in the top right-hand corner, this unit is going to delve really into what those mean. Okay, so we're really going to understand them a lot better when all is said and done. And we're actually going to be able to rebalance equations back from balancing equations based on electron transfer. So this is where we get redox from, a reduction and oxidation reaction. So reduction and oxidation stands for, we call it redox for short. So there's a reduction reactions and there's oxidation reactions, okay? They involve the transfer of electrons. Both reduction and oxidation must happen simultaneously. That means at the same time. I cannot have one without the other, okay? A reduction is specifically a gain of electrons by an atom or ion. The oxidation number goes down or reduces, and that's how we remember that. Okay, it goes down. Oxidation, specifically, is the loss of electrons, which is the opposite, okay? And the oxidation number is going to go up or increase. Now, we don't really have a way to remember that based on the word, but reduces and reduction are very close. So that's how we're going to remember that. We'll remember one and be able to figure out the other from it. Now, here's the first mnemonic, okay? Leo the lion goes grr, okay? And Leo stands for loss of electrons is oxidation. See that L, the E, and the O? That's Leo. And he says grr. Gaining electrons is reduction. So I need to, that's the way I remember is oxidation gaining or losing electrons. Is reduction gaining or losing electrons. Now I was always taught another way. So I'm going to tell you that other way because unfortunately I'm probably going to say it more in class and I'm probably going to say it more in the notes because it's how I remember it. Okay? I remember it this way. Oil rig. And that stands for oxidation is losing. That's a G, not a 6. Rig is reduction is gaining. One thing I want to be very clear about. Well, first of all, the reason why some people don't like oil rig is there's no mention of electrons. We have to assume that we understand that in redox we're dealing with electron transfer. So if we can remember that, oil rig will be just fine. The Leo says grr. Well, see, that has electron in it, so that makes it a little bit more, forthright, if you will. But the point I want to impress upon you is, whichever of these mnemonics that you like, I promise you, I cannot do these problems without these mnemonics. I write them right on top of the paper. It's just something you don't really want to have to memorize and get confused about. I just write it down. When I'm starting to do the problem, I figure it out. Which one does it fall? Oxidation is losing. Am I losing electrons? Oh, I'm oxidizing. And I just do it. And it's a process that I do. I've never really been able to memorize it, and I don't really expect you to. What I want you to do is use the mnemonic, whichever one you like. Leos the lion says grr or oil rig. And I want you to use it, and I want you to kind of use it religiously so that you don't ever have to memorize and have a brain spasm or something and get something wrong, right? Just use it and you'll get it. There's more mnemonics in this unit. This unit for me is all about mnemonics and getting everything straight. Oxidation and reduction happen because of the desire for electrons In a chemical reaction, species either prefer to gain or lose them. We did a lot of that with the periodic table, that, with the electronegativity and that kind of stuff. Okay. Oxidation reductions are mutual and simultaneous. They happen at the same time. I can't have one without the other. If I lose an electron, it's got to go somewhere. Somebody's got to gain it. So they do happen. They're every time. I can't have one without the other. If one atom loses an electron, there must be another atom that gains one. So the green chunk experiment, we very well may do this lab. I haven't decided yet or not, but here we go. I have aluminum is above Cu on table J, so it will replace it. That was the reactivity we did last unit. Notice how Al is all by itself on the left arrow, so then it's going to have a 0 charge. So we haven't done the rules yet, but whenever I have an element by itself, its charge is 0. Even though I see an element by itself on the periodic table and they have charges, the rule is in balanced equations. If an element is by itself, it's got a charge of 0. It is neutral, okay? Unless it specifically says it's an ion, okay? And then we're going to figure out what's going to happen to it as it does this reaction. So I look at copper is a +2, and chlorine is a -1, and I have 2 of them, which gives me my -2, but its charge is -1 for one atom, so that's what we do. Now, the aluminum and the copper are going to change places. I'm going to get Al, Cl, and I'm going to get copper. Now, copper's charge, because now it's by itself, is going to go to 0, and I have to figure out the Al and the Cl. So, of course, I know Cl is -2 or -1, and I had 2 of them. But let's see, Al wants to be a +3. Okay, so I'm going to need 3 Cl's when I crisscross. I'm going to need 3 -1s. So now here's the trick. I have to balance. So I have 2 and I have 3. I have to make it a total of 6. Is the only way I can deal with that 2 and the 3. So I need to multiply this one by 2 and this one by 3, and then both my Cl's will be at 6. And then it gets real easy because Al on the right-hand side, now there's 2, so I put a 2 there. Cu's on the left-hand side, there's 3, so I put a 3 there. I can balance the single element real fast because the coefficient isn't going to affect any other numbers. Okay, so we just assigned some oxidation numbers real quick. Now we need to be able to identify oxidation and reduction. So the one way we can begin to identify them is these oxidation numbers, and we're going to go over the rules of how we assign them. And I believe that's actually next video. Oxidation numbers are used to track the movement of these electrons, who's gaining, who's losing. I need to be able to know, right? The oxidation number states, right, I can have positive, I can have negative, and nothing is neutral. Oopsies. And I can also identify how many electrons are being lost or gained in an atom by the number of bonds that they form. So that's back to Lewis dot structures, right? The top listed number in the upper right, so in this case for carbon would be -4, is the most common oxidation number for that element, okay? The trick number 1, single replacement reactions are always redox. So it's always a single replace. If I have a single replacement reaction, it has to be a redox. And it has to be a redox because the Zn is going to start at 0, and that's part of the rules. We'll do all the rules next one. And here H is a +1 and Cl is a -1. So if I do my single replacement reaction here real quick, I'm going to end up with ZnCl and H. Well, H by itself is actually always H2, and it's going to have a 0 charge. And ZnCl, Cl is a -1. Let's see if I have a +2 for Zn on my periodic table. So I need 2 of those, and now I can balance real quick. I have 2 Cl's on the right, I need 2 on the left. I have 2 H's, I have 2 H's, I have 1 Zn, I have 1 Zn, and I'm all good. I have Zn and H2 are by themselves on one side of and bonded to the opposite side. So on one side, they're by themselves. So ZN's by itself on this side, H2 is by itself on this side. That's where I get that single replacement reaction. Second trick, double placement reactions are not redox. If I look at all my charges, when I take my plus with my negative and my negative with my plus, I get NaCl and HOH, and it's a -1 and a +1, and a +1 and a -1. The numbers didn't change. Notice they're all still the same. The Na was a +1, it's still a +1. Well, the way this oxidation reduction thing works is, on the first problem, the Zn on the left was a 0, and now it's a +2. So it lost 2 electrons. The H +1 went from +1 to 0. So it gained electrons. So that's where I see the oxidation and the reduction happening, is that changes, okay? In a double replacement reaction, the charges all stay the same on the left side and the right side. And we are done with video number 1. There is no practice, there is no quizzes. And now we understand a little bit about oxidation and reduction, and the two mnemonics that we use to tell which is which. And next video, we are going to figure out how the rules are to assigning oxidation numbers. See you guys in class.